In this quick video tutorial, what we're going to look at is an example of where we throw an object into the air and we talk about which way we should pick positive and how long it takes to hit the ground and how tall the building is and all this sort of stuff. So what we're going to quickly do is just make an example, make a little drawing of this as it says, so make a diagram. So basically what we're going to say is there's a building like this, and that there's a person at the top that's going to throw an egg into the air. So the egg will go up at some speed. I believe it's thrown upwards at a speed of 23 meters per second, and it takes 15 seconds to reach the ground, and we're trying to find out the height of the building. So for the diagram, we know that as it goes up, it's going to get closer and closer because it's decelerating. Now, I can't draw it right back on itself to come straight back down, so we just have to pretend that it is coming straight back down, but it's missing. So, and then the dots are going to get further apart because we know that if we look at the same time interval, it should be accelerating. So on the way up, it's slowing down, and on the way down, it's speeding up. Okay? So that could work. We know here that the height of the building, we're going to say, is the displacement. So it's delta D vector from where the object was launched to where it finally hits the ground. So that's the displacement. Now, a couple of really important things when we're solving problems like this. Whenever you're dealing with problems that have vertical direction, or even a horizontal, it doesn't matter, you should always pick a direction to be positive. In this case, I'm just simply going to pick up as positive. Just in this case, we'll just pick up as positive, and we'll see what the consequences of making that positive are. So, to start out with, what we need to first look at is if we make up positive, what is our value of v1, the initial speed? Well, it says that it's thrown upwards at 23 meters per second. Well, upwards is this way, so it's going to be 23 meters per second, positive, because that's in the positive direction. It says it takes 15 seconds to reach the ground. So that's just time, so it doesn't matter. And that's about it. The only other thing we know is that since this is an object in free fall, we know that the acceleration is going to be 9.8 meters per second. Now, here's the thing. Which way is acceleration? Acceleration is downward. Okay, so acceleration is downward, always in these cases, towards the center of the earth. Okay, and that's this side down here. Well, on the way up, the acceleration is down, which makes sense, and then it eventually stops and then starts to accelerate down and speed up. So on the way up, it's accelerating down but slowing down. And on the way down, it's accelerating down and speeding up. In any case, throughout the whole thing, the acceleration was downward. Now, because we made up positive, if the acceleration is downward, that's a negative direction, since it is, remember, a vector quantity. It has both magnitude and direction. Now, it could have angles to it and things like that, but in our problems here, we're simply looking at plus and minuses because we're talking about, one-dimensional kinematics problems. All right, it says calculate the height of the building. Well, we have no real way to do this yet except for to look at one of the equations that has v1, t, and a in it. The only equation is this one here, or there's other ones, but this is a good one that we could use. And I'm going to write the vector signs in there so that we realize that direction does matter, and that we're talking about displacements, velocities, and accelerations, not just distance, speed, and acceleration. It's always important to remember that. It's a really, really important point. At this point, whenever you're substituting in values, always include brackets so that you get the signs correct. Notice how here there's a negative now. Okay. And so the displacement of the egg from time t equals 0 until for this 15 seconds is 9.8 negative times 15 squared divided by 2, and then add 23 times 15, and we get negative 757.5 meters. Now, some people at this point panic a little bit. They say, what do you mean negative? What does that even mean? We're asking for the height of the building. Well, what this tells us, this negative sign, we chose up as positive. And if you recall that this is a displacement right here, then what it tells us is that when the egg was here, it went up some distance and fell back down that same distance. Well, on the way up, that's a positive displacement. On the way back to its original spot, that's a negative displacement, and they cancel each other out. It's the same distance, but one is in one direction, one is the other. So the displacement, if it starts and stops at the same spot, is 0. And therefore, the remainder of the displacement is just from the top of where you threw it to where it finished. So remember that displacement is always where did the object start, where did it end, regardless of how high and up it came back, because the up and the down cancel each other out, because it goes up the same amount as it comes down. So the displacement for that part is 0. So hence, by finding the displacement over the total time it took to go up and come down, we got negative because we are below where we started and we made up positive. So therefore, the height of the building from our diagram is 758 meters approximately. Okay, now some people at this point are like, well, what if I made down positive? Okay, and I'm going to do this with a different colored pen, but you don't need to include this part of it, so don't worry about it, okay? So what I'll do is draw it with the pen here, and if I made down positive, like this, so you're not adding this part to your note, if I made down positive, then the initial speed upward is negative, the time stays positive, but now the acceleration is positive. So when we come down here, this becomes negative, this becomes positive, that becomes positive. That's all that changes. It still doesn't change your answer that the height of the building is 758. All it does is change the fact that because this is negative and positive, it tells us that now the object displaced itself positively by 757.5 meters. So even though it went negative up, positive to here, they canceled out, and it moved in the positive direction for the rest of it. So you always have a choice of picking down as positive or up as positive, and then just maintaining the proper signage from there. It's up to you what you choose. In some problems it makes more sense to make down positive, in some problems it makes more sense to make up positive, but it doesn't matter in the end. If you like to pick one and stick with it, do that. Okay, calculate the maximum height above the building that it reaches. Okay, now here's a key point. We know that I'm going to keep up as positive just so that we stay with the original problem. V1 in that case was 23 meters per second. The acceleration was negative 9.8 meters per second per second. We're looking for the displacement, and that's unknown. And what we need to find out, this is sort of at max height. So you're probably looking at this thinking, I don't know what to do with this. I don't have enough information. I don't know how long it took to get to maximum height. I don't know the speed at maximum height. I don't know any of this information. But here's where you start to think about it. If you throw an object into the air, on the way up, it's going to get closer and 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 stop. And you just heard me say it. And then it starts to move back down, follows the same path. So on the way up, it's slowing down at 9.8 meters per second per second. On the way down, it's speeding up at 9.8 meters per second, which means at the top, if it had to switch from slowing down to speeding up, at the top, V2 equals 0. It stops briefly. So at max height. So we do know that V2 equals 0 at max height. Well, if that's the case, then we can simply at this point go V2 squared equals V1 squared plus 2a delta d. Again, I'll throw the vector signs in there. We're solving for delta d. It's a very simple rearrangement of the formula, like so. Plug in our values. So V2 is 0. Notice I'm being very, very clear about putting in the negative signs in the brackets. And our speed was 23 squared over 2 times negative 9.8 equals, so it's just 23 squared, which is but negative, divided by 2 divided by 9.8 negative, gives us 26.98. So basically the height above, and this is meters, so that was our displacement. So it displaced itself positively by 27 meters. So therefore, max height above building is 27 meters. Now, how high is it above the ground? 758 plus 27. And that's how high it would be above the ground in that case. So it would be about 785 meters above the ground. Now, what's neat about this is that, yes, the speed at the top is 0, but throughout this entire trip, the acceleration is always 9.8 meters per second down. Meters per second down. It's really important that you realize that the acceleration at the top is not 0. It would make no sense that as it went up in the air, if the acceleration became 0 and it also stopped, it would just hover there and never move. So that makes no sense whatsoever. So it's decelerating, it's slowing down at 9.8 meters per second, and the minute it reaches the top, it starts speeding up at 9.8 meters per second. At no point is it 0. Otherwise, it would literally hover at the top. All right, calculate the impact speed. Well, I'm going to stick with my up as positive. We know that V1 is therefore 23 meters per second. We know that the acceleration is still negative 9.8 near the surface of the Earth, meters per second. We know that the time it took to do the full trip was 15 seconds. We also just found out that the displacement it makes for the whole entire trip is negative 757.5 meters. Sorry, I didn't mean to put that extra decimal point there. So we have lots of information to figure out what our final solution is, and we're just trying to solve for V2. There's two ways of doing this. There's a simple way, which is this one. V2 equals V1 plus A delta T. V1 is 23. The acceleration is negative 9.8, and the time was 15. So this thing will slam into the ground at 9.8 negative times 15 plus 23 at negative 124 meters per second, approximately. That's very fast. It's about 446 kilometers per hour. Okay. The negative just tells us that it's moving downward. Since we chose up as positive, it's moving downward at negative 124 meters per second. Second method, you could have actually discovered V2 by using the other information that we had. V1 squared was 23 squared plus 2 times negative 9.8. Notice how I'm putting the signs, and therefore the negative signs and positive signs matter so much. Like, they're super important. Now, if I put this in my calculator, I get 757.5 I get this. I get that V2 squared is equal to 15,376 meters squared seconds squared. Notice it's the wrong units, and that's because it's velocity squared that we have. To find V2, it's plus or minus square root of that number. So the answer is going to be plus or minus 100. If you take the square root of that number, you get 124 meters per second, but it's plus or minus. At this point, you have to think about the problem. Remember that anytime you take a square root, there's two roots to any quadratic equation. Typically, there could be one or none, but at this point, we realize that there's two possible roots that we could get. One of them is the correct one. Since we chose up as positive and it's hitting the ground, we have to consciously choose the negative 124 meters per second. That's super important. Whenever you write the square root, always put a plus minus. Your calculator should do it for you, but it doesn't. And you see you get the same result. Okay, some other things. Calculating the maximum height. When we calculated the maximum height, we could have also found out how much time it took to reach the maximum height. Okay? And we could have done that simply by a very quick calculation. Now I'm going to do this. Don't write this down. Please don't write this down. You could do V2 equals V1 plus A delta T. And solving for the time it takes to get to the maximum height, we know that v2 is 0. So really we're going to end up with negative v1 over a should tell us how long it takes to reach maximum height. And if I took 23 negative divided by 9.8 negative, you get about 2.35 seconds. So you knew that it took about 2.35 seconds to reach max height. Okay? And that means that if it took 2.35 seconds to reach here, and then 2.35 seconds to reach the top of this hill, or top of the building again, you're at about 4.7 seconds. And that's about 5 seconds. So then you know it takes about 10 seconds to fall the rest of the way. So there's lots of other ways of solving this and figuring out, like, time to max height and things like that, and different ways of even solving the general solution to these problems. You don't have to do it in the method I showed here to get the answers. There are multiple steps you can take to get to them, but in the end it should all work. And again, always make sure you're choosing up or down positive. Make sure that you're putting in the correct positive and negative signs. Make sure you're including brackets, and also make sure that when you take the square root of your answer, you pick the positive or negative and choose it accordingly, and make sure you pick the right one. And the last thing is to always remember that these are all vector quantities, and therefore we're not talking about distances whenever we do these problems. We're always talking about displacements. Okay, hope this helps.